Hello everyone, welcome to the session number 6 on Introduction to Statistics. And today is day 6 and we are discussing about the representation of qualitative data in the form of charts and graphs. So in session number 4 and session 5, so we discussed about pie charts, right? And then we discussed about bar graphs. So then today's session I will be focusing on one specialized type of bar graphs that is called a Pareto charts. Clear? So this is about me. So you can follow me on LinkedIn. So this is my LinkedIn ID. So as we know that there are many ways to represent the data, and our main focus now is qualitative data because we wanted to complete first this. So in that part we are done with pie charts and bar graphs, and today's focus will be Pareto charts. So let us understand where we use these Pareto charts and what are these Pareto charts. Okay, so to understand, let me show you how the Pareto charts looks like. If you see here, look at it. So the Pareto charts are both a combination of bar graph plus line graph, right? Line graph. So these Pareto charts are nothing but, as we know that as they are consist of bar graph, so they are just a specialized type of bar graph, right? So we use these Pareto charts especially where we will be talking about quality management, and we will be where we discuss about the production and services, and we wanted to identify the defects, the problems, the problem causes, right? So because when we were discussing about the quality management and production services in those fields or in those areas, what will happen unless if you don't know the problems, what is the major cause, what is the major problem, right? So then we it will be very difficult for us to work on the improvise the quality or bring the efficiency, right? So therefore, to understand that, so we use Pareto charts. So these Pareto charts are named after an Italian economist, Vilfredo Pareto, right? So as I said, so we use these Pareto charts in quality management and to improve the work quality, right? Efficiency. So in those, so here, so these bar graphs, as I said, so these bar graphs just like how we draw. So one side you will be having the categorical data, its corresponding numbers, and then this line graph is formed by taking the cumulative numbers. So why? Because we want to know which is a major cause, right? I will show you with an example. So before that, so there is a one famous like a Pareto rule. So that Pareto rule says that it always discuss about 80-20, 20-80. Okay. So yeah, let me erase this. So that rule says that it is divided into two parts. One is 80, another one is 20, other way. So 20-80. So 80% of the business comes from 20% of the customers. 20% of the problems cause 80% of cost of poor quality in a company, and 20% of the parts account for 80% of the inventory. Our managers spend only 20% of the time completing 80% of their work. Okay, so this is a famous Pareto rule, 80-20, or you can say 20-80, right? So let me take one example. Suppose here we have a company which is dealing with the electric motors, okay, and these electric motors are rejected by the inspector, right? When he go for the quality management, quality inspection, so he rejected. So company officials wanted to know, like why they got rejected and what is the major cause, what is the major reason they got rejected. So therefore they wanted to know that the defects, right? So they found out that 40% of the defects involved poor wiring, and 30% involved in short of in the coil, or 25% involved in a defective plug, or 5% involved in seized up bearings, right? So to understand that, so this from this also we can understand why we use graphs and charts, because a visual representation makes us a very attractive, and it will give a glimpse. We can, by looking at the graph and by looking at the charts, we can get the easily, right? Okay, this is a major and this is a minor cause, right? So that is the use of, that's why we represent the data in the form of graphs and charts. So let us draw first bar graphs, right? So how we'll draw, like as usual, we represent these defects on x-axis, and then the percentage of each defect is on y-axis. Okay, so now as I said, these Pareto charts are both combination of both bar graph and line graph, right? So how would you get these? So this is starting from, like as I said here, the person, see, as I said, it is a cumulative. The line graph is obtained by taking the cumulative. So this is 40. How will you take the cumulative? Cumulative is nothing but add to the next one. So therefore here 40 plus 30, which will give you 70, and 70 plus 25, which is equal to 95, and 95 plus 5, which is equal to 100, right? So these numbers 40, 70, 95, 100 will be formed by this line graph. Okay, so these numbers, this is 40, and this is 70, and this is 95, and this is 100, right? Now from this we can understand that, by according to the Pareto, almost you can see this is a major cause. So almost, see the around 80% of the problems are causing of because of poor wiring and the shorting coil, right? So these are all the major defects. So that is the conclusion we can draw from the Pareto sets. So these Pareto sets generally we use in the advanced statistics, right? Advanced statistics. So with this session we are concluding the representation of qualitative data, right? So maybe in the next session or one extra session, what I will do, like we know how to draw pie charts, bar graphs and Pareto charts, but what I want to do, when you move to the advanced level of statistics, we don't do generally draw these charts and by using the graph paper or pen and paper. So we try to use Excel, right? So therefore what I will do in the in next session or maybe some other session, I will take one session on the Excel, how to draw these graphs in the Excel. Okay, so that will give you the more clear idea, because that's how we use that is a more convenient way to draw these graphs. Okay. Okay, so that is all from my side for today's session. Okay, thank you, thank you so much.